Radial Engine Assembly, Part 1. Please pause and read this slide carefully. It is important that you have these settings in order to go on. Begin the piston head by choosing the YZ plane and start with a simple rectangle shape in order to create the cylindrical outline. Set the width of the rectangle to 46.5 millimeters, which is half the overall diameter of the piston. Then, place a very large circle in your sketch and set the radius to 189 millimeters. Apply the coincidence constraint on the center of the circle to the left vertical segment of the rectangle. Seen here is how the coincidence to the left segment of the rectangle keeps the circle locked on that axis. Then, constrain the edge of the circle to the top left and right corners of the rectangle. This will, in effect, create the curved surface of the top of the piston. Use the trim command to get rid of excess parts of the circle and rectangle pieces as seen in the video. The process of creating the profile is somewhat tedious, so this process has been sped up and will now be shown carefully with a zoomed-in view. Here we can see the bottom of the piston, and as we move up, we see the ridges of the upper section of the piston as they correspond with the radial curve. All of the dimensions were taken directly from the schematic that was shown at the beginning of this section. Now come out of Sketcher, choose a profile, and then select the Shaft command and create a 180-degree shaft. Select the flat face of the piston as shown and go into Sketcher. Here, make a construction line, and with the Symmetry command, center this line. And then constrain another rectangle as shown. The use of a construction line at the base of the piston is recommended in order to keep your rectangle centered and properly constrained. And remember, all of the dimensions were taken from the earlier section of this video. Once your rectangle has been constrained, as shown, go out of Sketcher, select the Groove command, and then the sketch, and make a 180-degree cutout, as shown. The rough outline of the piston has been created. Now we must create a plane that is offset by the maximum radius of the outermost dimension of the piston, and this is 46.5 millimeters. This is so that you can have a plane that is perpendicular to the rounded surface to create the counterbore hole. To make a hole, you must select the hole command, and then the plane, and then go to the Position Sketch option. At this point, you should center the hole based on the dimensions that were given at the beginning of the section. Here we see the versatility of the Symmetry command when attempting to center the hole along the horizontal axis. If needed, please pause the video and make sure you follow the precise motions in the whole command menus. At this point, we will now be ready to create the raised intersection of the piston. Now we are ready to create the inner raised circular ring. This will be done by creating a plane that is 25 millimeters away from the YZ plane. This will effectively create the base of the inner circular ring that you see if you were to turn the part. Shown here is a common process of creating the required sketch that will be padded. We will now use this sketch in combination with a pad command and select the up to next option. This will effectively force the sketch to mold to the inside surface of the piston without passing the external geometry. As a beginner, it is important to always double check your work as you move along. Finally, use the mirror command on the part and select the YZ plane as your mirroring plane. And if you follow these steps, you should now have the piston head complete as shown.
Next is creating the articulated rod. In this part, following commands will be shown. Click on the YZ plane and enter Sketcher. Using the circle button, create two circles of radius 12 and 17.5 millimeters. Using the line button, create two horizontal lines. Selecting the end point of the line and the circle while holding Ctrl key, click Constraints Defined in Dialog box button and select Coincidence. Do the same step for the other line. While holding the Ctrl key, select the two lines in the center of a 12mm radius circle and click Constraints Defined in Dialog box button and select Equal Distance Point. It is important here to select the two lines before the center of the circle. Do the same steps to the 17.5mm radius circle as done on 12mm radius circle. The space between the two lines is 18mm. Click Constraint button and select the two lines. Double-click on the green constraint and change the value to 18. Do the same for the center point of two circles. The distance is 178mm. Click on the Quick Trim button under the Delimitation toolbar and click on the edges shown in the video. To find the Quick Trim button, simply click on the black triangle to show all the buttons under the Delimitation toolbar. Exit out of Sketcher and click on the Pad button. The pad length is 21mm. Click on the top surface and enter Sketcher. Create a circle and click on the top curved edge of the padded part. Click Constraints Defined in Dialog box button and select Coincidence. Do the same for other bottom curved edge. Selecting two vertical lines while holding the Ctrl key, click Project 3D Element button. This will automatically create a line that is aligned with the padded part. Using the Quick Trim button, select the edges shown in the video and exit Sketcher. Click on the Pocket button. The depth we want pocket is 12mm. Now, select the top surface of smaller circle and enter Sketcher. Using the Circle button, create a circle that has coincidence to the padded circle. Exit Sketcher. Again, clicking the Pocket button, pocket 7mm. Now, creating the pinholes. Select the surface you want to create the hole and click the Hole button. Please follow the video. Here, up to next is chosen since the hole goes all the way through. There are 5 modes that can be chosen. Choose the best one for your part. It is important to click on the positioning sketch to make sure the position of the hole that's been created. Do the same step for a roller rod. Now, creating the elongated hole in the arm of the rod. Click on the surface and enter Sketcher. Find the elongated hole button under Predefined Profile toolbar. Define the length and radius of the elongated hole. Here, the length is 130mm and the radius is 5mm. Position the elongated hole with padded part using the constraint button. Be sure to constrain it in horizontal and vertical direction. Check all dimensions and exit Sketcher. Click the pocket button and depth is 6.5 mm. Looking at the part, the arrow is pointed up. This arrow shows the direction of the pocket. In this part, we want the arrow to point down. To do this, click on the reverse direction button or click on the arrow. Select the bottom surface and click on the mirror button. Now the base part is finished. Next, select the inner 4 edges and click the Edge Fillet button. The radius is 24 mm. Check the part. The articulated rod is complete. Piston pin, rod bush, bearing, piston pin plug, link pin can be made using shaft command. This video will be skipping these parts since it can be created easily. Next, piston ring will be made. The ring can be created in the same way as piston pin, but in the video, it will show the method of creating a gap in the piston ring. Having the circular ring, click on the point button in the reference element toolbar and create a point on the outer surface of the ring. Clicking the plane button in the reference element toolbar, change the plane type to tangent to surface. Then, select the outer surface of the ring and the point created earlier. Now, the plane tangent to the outer ring is created. Enter the plane created to create the slanted gap. Here, the rectangular button is used to create the gap. The 1 mm gap distance is constrained using constraint button. 2B is deleted since the side edges are going to be diagonal. Top and bottom of the rectangle is constrained to the ring by selecting coincidence in the constraints defined in dialog box button. Selecting the one of the side edge and the bottom edge while holding Ctrl key, angle is constrained as 135 degrees. Constrain the point created in the center of two diagonal lines. Exit Sketcher and click Pocket. Choose a pocket type as up to next since the gap is at the single spot. Check the part. Now the gap is created in the ring. Next video is the creation of master rod. Thank you for watching part 1 of the radial engine assembly tutorial.